Hi everyone. Today we want to learn chlorophyll concentration mapping with a MODIS satellite. As you know, the chlorophyll is a critical pigment found in the phytoplankton and other algae that enable them to perform photosynthesis, and it absorbs light for photosynthesis and is a vital indicator of a marine ecosystem health. Chlorophyll concentration is commonly used to monitor ocean productivity and algae blooms in both coastal and open ocean environments. So why chlorophyll is important? Because ocean productivity, chlorophyll serves as a proxy for primary productivity because its concentration reflects the amount of phytoplankton biomass, which is the base of the marine food chain. And secondly is monitoring the algal bloom, and high concentration of the chlorophyll indicate potential algal blooms, which could lead to hypoxia, low oxygen, or eutrophication or nutrition enrichment, which are harmful to marine ecosystems. And third one is marine ecosystem health. By monitoring the chlorophyll, we can assess the overall health of a marine ecosystem and track change to the human impact, such as pollution or climate change. The unit of chlorophyll concentration is measured the milligram per cubic meter. Higher chlorophyll concentration typically correspond to more productive water, like the coastal upwelling regions, and will lower concentration indicate less productive oligotrophic waters like the open seas. So in the code.fng, we want to implement this step by step, and this code use GE to analyze, to visualize the chlorophyll concentration of a region of interest, specifically the Gulf of Mexico for the date range using the MODIS-Aqua Ocean Color data. And in step one, we define the area of interest or AOU like this. We define the geographical region and we are interested in. For this example, we are facing on the Gulf of Mexico near the Texas, and the area as a bounding box using the rectangular geometry. You can watch the Create bounding box video in the training playlist. After this, the rectangle spans the coordinate -98 to 18 lower left to -80 to 31 upper right. And map center object and center the map on this region and set the zoom level to 6. If I run this, you can see we zoom in the area of interest, and in the second steps, uh, we load the MODIS data, Aqua Ocean Color dataset. We load this dataset for the specific data range. The dataset contains global ocean color observation, including the chlorophyll concentration, and which is the main variable we will analyze. You can explore more of this dataset here, the availability from 2002 until 2022, and temporalization 1 day. Describe the different bonds here, and you can explore more with the documentation. So the filter data from 2021 0601 until 2021 0731, and we select the color underline A, the chlorophyll concentration bond, which provide the value of chlorophyll concentration in microgram per cubic meter. Step 3 is a create a mean composite. Some of the dataset contains a multiple image over the selected time period. We calculate the mean composite of chlorophyll concentration for the given data range. And that mean here average all image in the selected time period and smoothing out any short-term variation in the chlorophyll concentration. And that clip Gulf of Mexico ensure that the analysis is limited to the Gulf of Mexico region, defined in step 1. And after this, we define a resolution parameter like this. Here we define how the chlorophyll concentration will be visualized on the map. The mean and max values set the range of a chlorophyll concentration, and the color palette is used to represent low to high chlorophyll values. And we define to 0.01 until 10, specify the range of a chlorophyll concentration to visualize. And the color class spans from the dark blue for low concentration to red for high concentration, and create a clear representation of the chlorophyll levels across the region. And the final level is at the posted chlorophyll mean composite to the map using the defined resolution parameters. And this added the processed chlorophyll layer to the map from the step 4 and display the chlorophyll concentration across the Gulf of Mexico. If you run this, you can see in the coastal area we have a high chlorophyll, and in the ocean areas we have a low chlorophyll. And based on your needs, you can change this time period, for example, change to one again. Yeah, for this type, because yeah, it's February, almost 31 days. Yep, like this. And you can analyze the time series of chlorophyll shrimps. This type of analysis is used for various applications, such as a marine ecosystem health monitoring. Helps to track algal blooms, which can lead to harmful eutrophication or hypoxia, and support the management and conservation of marine biodiversity. And other application in fisheries and agriculture. Chlorophyll concentration is a proxy for primary production, which directly influences the fish and shellfish populations and can be used to assess the productivity of a fishing zones. Other application is climate and oceanography studies, helps in understanding ocean productivity, response to the changing climate condition and sea surface temperature. And other application is water quality monitoring. Elevated chlorophyll concentration can indicate pollution or nutrition loading in the coastal areas, which may affect the water quality. So this GEE code provides a simple and effective method for visualization and analyzing the chlorophyll concentration. By following the step-by-step implementation, user can monitor ocean productivity and detect the algal bloom and analyze the health of marine ecosystem in any region of interest. Please like and subscribe this video and watch all other videos. Thank you.